So here's an example for graphing cotangent. We definitely should have started with this one. I definitely think it's easier than the tangent one that we were working on, but now we can just go into the easier form. So let's go ahead and label all the pieces out. A is 1, because there's nothing in front of that cotangent. B is 1/2, which means that my period is pi over 1/2, which turns into a 2 pi. So, let's see. My iPad's giving me issues. There we go. All right. That's going to be from my transformed table, and down here I'm just going to do my regular cotangent table, you guys. Cotangent, that table that we did, goes from 0 to pi. Pi over 2, pi over 4, 3 pi over 4. It's undefined. 1, 0, -1, undefined. So that's the parent or the plain old cotangent table that we're going to use to morph our graph. So the period of the original is typically a pi, and now we're at 2 pi. So that means we are going to be going from our first point at 0 to 2 pi. And then you guys know this because this looks like, what the regular sine and cosine look like. This is just 1/2 cotangent. So it's going at 1/2 the speed, and that's why it's taking twice as long. Those of you that drive can probably make this connection better than those of you that can't drive yet. All right, now our y value, if you notice, a is 1. Nothing is being changed to our y value. It's the same as the parent graph. So that means we have undefined 1, 0, -1, and undefined. Those are our 5 points, and we are ready to graph. This one is loads easier than the other one. It only has one piece to it, and it's nice numbers. Label your graph. 2 pi, every tick mark is a pi over 4 marking. 1 and -1. At 0, it's undefined, therefore we have an asymptote at 0. And at pi, it's also undefined. I typically like to put my asymptotes first when I graph, so then I'm kind of going in the, I'm looking at what it's stuck between. Then at pi over 2, I have a point at 1. And then at pi, I have a point at 0. And then at 3 pi over 2, -1. And this right here is the graph for g of x equals cotangent 1/2 x. And that's it for this one. I'm going to go ahead and let you guys go into doing your homework. I will link a couple more examples for you. They are not required for notes. It is very pattern related, so if you guys are getting the hang of it, I won't make you sit here and do more. If you need more, I've got a couple extra videos on the next slides, so take advantage of that.